All right, well, let's go ahead and get started. We only have 35 minutes, which is not a lot of time to cover everything that we want to cover. But thank you all for coming to the Linkerd intro session. My name is William Morgan. I am a contributor to Linkerd, at least nominally. Most of my contributions these days come in the form of emails and tweets, and not in the code. But I am officially a contributor. Thank you very much for being here. What we're going to try and do in this intro session, since a big focus of the Linkerd project is on the community, is I'm going to actually bring up 3 of our community members to give them to have them do some very quick lightning talks. And I think there's kind of a really interesting cross section of represented in the lightning talks. So I'm going to start with a quick overview. We're going to bring up Will King from Hush. Ivan Sim will talk about some of his contribution experience, because he contributed a bunch of code recently to Linkerd. And then Sebastian Tiedtke will talk about amazing and strange security stuff. And then if we have some time at the end, I'll do a little Q&A. And then I should also mention, I'll bring this up again as we get near the end, but immediately after this talk at 2:20 in this very, very room, Oliver Gould, who is the kind of creator of Linkerd, is going to be doing a deep dive into 2.0 and some of the design decisions that went into that. So you can just sit here for even longer. Okay, so what is Linkerd? Linkerd is a service mesh. For the past couple of years, every time I've said service mesh, I then had to spend like 5 slides describing what a service mesh was. This time, I'm just going to assume that you know what it is, and if that's not true, then I apologize. Just quickly Google it. It's a CNCF, Linkerd is a CNCF member project. We were actually, I think, project number 5, back in the kind of earlier days of the CNCF. And Linkerd's been around for a couple years, actually. We've been in production for over 2 years. We've got a very healthy Slack channel, all sorts of GitHub stars, which power the project, a lot of Docker Hub pulls, a ton of contributors, and then it sees a fair amount of production traffic. And I put up some of the fancier logos here from contributors and adopters, but there's a lot more. And if you look on GitHub, everything is on GitHub. It's 100% open source and Apache v2 and all that good stuff. So everything is available, kind of the source of truth for everything is GitHub. And then if you look at the history, so, I mentioned it's been around for a while. Linkerd 0.1 was actually released in 2016, which was a long, long time ago in the cloud native world. That was back when the dinosaurs were scheduling containers. And then about a year after that, became a CNCF project. And then, service mesh became a thing, and lots of other service meshes came into existence. And then we also learned a lot of stuff around kind of helping our users and adopters get Linkerd into production. And so we started working on the next version of Linkerd, and 2.0 was released in September of this year. So currently, there's basically 2 versions of Linkerd that are a little bit different, but that are both in production. And that we both continue to support and invest in. One is the 1.x stack, which was built off of the Twitter stack, so things like Finagle and Netty and Scala and all that stuff. And then the 2.x stuff, which Oliver's going to be talking mostly about in the deep dive session after this, is built on Rust and Go, primarily Rust for the proxies and Go for the control plane. So I'm not going to go in this session, I'm not going to go too much into the architecture and things like that, but there are these 2 versions, and which version you're using often depends on kind of how long you've been a Linkerd user. So that's it for me. You're not going to hear this beautiful voice for too much longer. I'm going to turn it over to our very first lightning talk presenter, which is Will King from a company called Hush.
Thanks. Cool. So I'm Will. I'm from a company called Hush. We're a social commerce startup in Los Angeles. And I'm going to run you guys through a little bit about how we're using Linkerd in production and give you kind of a brief demo of how to use Linkerd to fix your own production issues. So we started with Linkerd back in 1.0 around a year ago now, and when we initially saw Linkerd 2, we obviously wanted to try it out. And you can actually run the two side by side in your infrastructure. You don't have to really make a choice. Linkerd 2 works alongside Linkerd 1 really easily, and we actually do that today. Not all of our stuff is moved over to Linkerd 2, so just wanted to shout out if anybody is using Linkerd 1 in the room. It's pretty easy to try out 2.0. So we actually use Kubernetes admissions controllers to add Linkerd to all of our pods. For you, those of you who don't know what that is, I'm sure most of you do. Admission controllers are basically webhooks that can validate or mutate incoming Kubernetes API requests. And like I said, we're using that to inject Linkerd 2 into our pods. So fairly easy to check whether or not you have admission controller support. EKS just got support for admission controllers, so if you're running EKS, you can now do this. Yeah, you can run that command there, and if that output shows up, you have admission controllers. And it's pretty easy to get started with it. You just run that command, and you add that little proxy auto-inject param there, and you're good to go. So now let's jump into a demo. So off the bat, I'm going to start out by running Linkerd check. And that's just going to verify that Linkerd is up and running in my cluster. That's super useful to run between upgrades. It's really awesome. Yeah, let me do that. Cool. So now we're going to start up the dashboard here. And this is kind of an out-of-the-box dashboard that Linkerd gives you. And we can see here that we have 3 services in our mesh: a cart service, an account service, and a merchandise service. And the cart service is going to call those 2 services. So now we're going to introduce some traffic into our cluster, doing this one-handed. Cool. So now we're adding a new deployment here, which is going to introduce traffic to our cart service. And this is all going to be traced through Linkerd. And if we start up our Grafana dashboard as well here, we can see in a second, when stuff goes through, that we actually have requests going through the system. Currently 100% success rate, so everything's hunky-dory. If we can go down here, we can actually also see what other 2 services are being called by our cart service, which is really, really useful when you're trying to figure out what's going on in your environment. So now let's introduce some layers of failure. So once that redeploys, we're going to see that the success rate is going to start dropping to around 50%. Yep, there we go. Success rate's going down. So now, if we want to see what's going on, we can click into our cart service here, and we can see that, just like I said, we have a demo service that's calling cart. It's failing, and it looks like it's actually our account service that's failing right now, but our merchandise service is good to go. So we can kind of scroll down here, and we can see that there's an inbound call here, add to cart, that's failing, and there's an outbound call from our cart service to a get account call that's also failing. And we can go ahead and check out tap, and we can see a live history of all the calls as they're going through the system, which is good for kind of ad hoc debugging. And if we go down here, we can see that our gRPC status code on one of these calls is invalid argument. So, okay, type, we fixed our problem. And if we go back up to 100%, we'll be able to see here that this will rectify itself. The success rate's going to go back up to 100%, and we've successfully used the Linkerd dashboards to fix our problems. So that's actually it for me. It was a really fast demo just to kind of do a quick illustration of how you can do this. If you guys want to see the source code for this, it's on GitHub. It's super simple source code, but it might be useful for somebody nonetheless. And that's it.
Thank you, Will. Thanks. All right, so next up we have Ivan Sim, who is from a company called Traction Guest. And the very same admission controller stuff that Will just mentioned was actually a massive PR from Ivan just a couple months ago. So already powering companies in production.
I know this is going to happen. Where's
I see colors.
all the way to the left? All the way to the left. My left or your left? Our left. So, oh, there it is. I mean,
Ivan uses a Linux laptop, so we all know who to blame.
Just bring my slide over to the other side. Sorry, my apology. Can't really see it.
Okay.
All right. Hi, everybody. My name is Ivan Sim. I work for a software company called Traction Guest, based in Vancouver, BC. Today, I'd like to share with you my experience as an open source contributor to the Linkerd D2 project. Just out of curiosity, how many of us are currently a contributor to the CNCF project? Whether your free time or paid? Okay, great. 500 of you. So I'm going to start off by telling you a little bit about what I like about Linkerd D2. And then I'll share with you some URL that have some contribution materials there for you to refer at your own leisure if you decided that contribution to Linkerd D2 is something that interests you. And then I'm going to quickly talk about one particular contribution opportunity that's coming up that may be of interest to some of you in the room. So very quickly, I first came across the Linkerd D2 project about 6 months ago. Back then, it was still a POC project called Conduit. And my first impression of that project was it was very easy to reason about. And what I meant by that was I was able to go into GitHub and look at the source code and follow the code path and actually understand what it was doing. I like it when I understand what code is doing. There was no insane configuration permutation. There were no different installation paths and hence upgrade path for different environments. It felt like everything was just right there in front of me. And it was simple yet powerful, and I like it. And as I continued to look through the code, I felt like, hey, I didn't have to fork multiple repositories. I didn't have to open up multiple tabs on my web browsers to look at the documentation of different libraries. The code is just there. And because the code was so easy, at least for me anyways, to understand, to follow along, it really didn't take long for me to start submitting pull requests to the team. Started off with something very simple, and then as I became more comfortable with the source code, as I became more comfortable with the community, I started to submit more pull requests with heads up to the core maintainers. And my latest contribution to the project was actually the proxy auto injection feature. If you look at that screenshot there was 60, 70 something comments between Kevin from Buoyant and myself. It was all positive and productive conversation. We're just trying to hammer out the details around the proxy auto injection features. So it really spoke two things to me. First of all, the core maintainers from Buoyant is very welcoming towards new contributions and pull requests and new contributors. And secondly, it doesn't mean anything go. The core contributors of maintainers are very mindful of what they got merged into the master branch. I really appreciate the effort they put into making sure certain features get included and certain features not get included to avoid feature bloat. And yeah, overall, it has been a very positive experience. I'm gonna put up the URL of the Slack channel. I invite you there to join. And one of the things that I really like about the Slack channel is that it's not just the core maintainers who are answering questions. There are other contributors like myself that are hanging out there and just trying to understand the problems that others may have come across or sharing our experience as well. And if I did my math correctly, with Linkerd 2.1. The number of components that actually got deployed or installed is very minimal. That with mutual TLS, proxy auto injections and telemetry all enabled, there were about 6 deployments and a couple other services, config map and service accounts. So relatively speaking, it makes me feel more comfortable putting this into production because I could actually reason about it and look at what is going on there. And if you are concerned and you don't like cluster roles, there's a new flag that they introduced that you can switch it over to just role, namespace roles. And with that said, these are the 3 key URLs. If you want to take a selfie with it right now, I'm not going to judge you on that one. Go on to the Linkerd/slack.com. There's a Linkerd 2 channel there. Go ahead, sign up, join. Most of us are there hanging out in terms of repositories, control plane, return and go, and then the Rust repo, the proxy, return in Rust. That's a URL there. And also, like for those of us in the room who have experience working with Go, and you want to be like want to get involved in a CNCF project, feel free to come to chat with me or any of the core maintainers afterwards. Because one of the things that we want to start working on next year, early next year, is towards the maturing of the auto proxy injections features after like a few months of experimentations and gathering feedback from the rest of the community. For those of us who are interested, as part of this talk, I actually prepared like some performance test results between like a Linkerd mesh setup and an SDO mesh setup. So if you're actually interested, come and talk to me afterwards. I have all the slides here, but I don't have time to go through them. So with that, I'm done. Thank you very much.
All right. Thank you very much, Ivan. Next up is Sebastian from a cool company called SmallStep to talk about some of the TLS stuff. I'm going to ask you to hold questions until after this talk. This is the last lightning talk, and then we'll just do like a big Q&A session. We should have enough time for it, unless Sebastian takes a really long time.
I'm going to take a real long time. Hey, so my name is Sebastian, last name Tiedtke. It's a little complicated. I'm the CTO at a company called SmallStep. We are a company that is concerned about access, and we use identity as sort of like the new perimeter of access and securing your services. And I want to talk to you today about mutual TLS and Linkerd. This is a preview, so just calling that out. This is not yet available, but we're working on that. So deep down, we believe that your microservices deserve great security out of the box. And in fact, what we think, how you can do that is by using mutual TLS backed by a world-class public key infrastructure. Some of you guys might already know that like Linkerd has to some extent like mutual TLS support. Our toolkit, SmallStep's, we call it STEP, is essentially like a world-class public key infrastructure that is fully featured. And what we've done here is combine Linkerd and STEP to like deliver that experience, right, of like a fully featured certificate authority and a PKI and to deliver mutual TLS. In fact, we just dropped our STEP certificates, which is an online CA as an open source project that you can access under the URL that I called out here. Without further ado, let's check out a demo. So in this video, I'm gonna like essentially like walk you guys through the steps. So we need to install the Linkerd into our cluster, and there's some additional command line flags to also provision a CA and bootstrap a PKI at the same time. So I'm not gonna go into the details here, what the command line flags mean. Just like in the other demo, we need to make sure that everything is ready. This will actually fail the first time because I was a little bit of an eager beaver and Kubernetes wasn't ready. But the second time it will go well. And the version checks will fail because I built it from source. Next thing is we're going to launch the dashboard. You guys have just seen that. It will come up. It's nice and green. And that will essentially allow us to see our services. And later on, we will see how we are upgrading a service from a non-TLS protected app to TLS, mutual TLS. So you're injecting the app here without mutual TLS. So it'll come up in here. We're looking at the Emoji Vodo app that Buoyant has put out as an example app. And it's taking some time to get ready, and we're just making sure here by printing the logs to see that like traffic is coming in. And there's this thing called VoteBot that just generates like random votes on that Emoji Vodo app. And as you can see here on the right side in the TLS column, there's like 0%. So like right now everything is plain text, no mutually authenticated connections. So let's upgrade that to TLS by essentially injecting an additional command line flag here. And what that will do is like it triggers a new deploy that will replace the pods, and mutual TLS will kick in. So here we go. On the right side, you'll see how that slowly creeps up. In the bottom section, it's already at 100% because it's it's the pods, and on top is the deployments. And soon enough, we will have 100% here. And there's more to it. when we look at the certificate authority steps certificate here, the logs, we can see how every service is like actually fetching a certificate. And what we're doing here is we have very short-lived certificates. They only like last for 5 minutes. So every minute we actually rotate the certificates in every pod. So when you look at it here, like at 22:57 military time, was the last time every service got a new certificate. We had 100% TLS coverage now. And when we go back, you'll see that the certificates have already rotated. So a minute later, I edited the video a little bit, you have 258. So it means like all the services now have a certificate that is renewed. And essentially that sort of makes up my demo. Jumping back here. So just to summarize, like from a block diagram perspective, on top, a highly simplified architecture here. You have two pods that are essentially service meshed with Linkerd, so it injects a sidecar Linkerd proxy. And using this TLS support, it also injects a step sidecar that is the renewer. And they have a shared disk, and the renewer fetches a certificate from the CA that's running here on the bottom. And those two pods do that independently. They have their own private keys. They never leave the pod. There's a bootstrap protocol between the two that's using like tokens to essentially fetch that certificate and then renew it afterwards. And you can just expand that out to like your application and all your services. So just to summarize again, like what we are using here is like step certificates, which is like a fully blown PKI. It meets and exceeds like most of the companies and InfoSec teams like security requirements. It has short-lived certs, so they're not like valid for a whole year. Sometimes they're valid for an hour or like 24 hours, something short-lived, right? And this PKI is also very flexible, so it's like you can use it beyond mutually authenticating services in Linkerd. You could use it to essentially like run like secure services that run across different clusters or services that run in a cloud setup that is not running at Kubernetes at all. So you can like kind of like cross connect them, you can federate them, you can like hang it off your existing PKI, and there's a whole lot of like other features that we support here. And at the end of the day, if you don't care about any of that, it's really easy to deploy and it just works. So yeah, that's the demo. Linkerd and Step. Please, if you want to take a closer look what's going on there and all that, come talk to us. Myself, Sebastian, and my coworker, the CEO, Mike, is here. We kind of hanging out in the vicinity of the Buoyant booth, and I'm sure if you ask for us there, they will find us too. Also, Twitter. We're gonna put out that video and the slides, after this, so you can, review that on your own time and check out those links. And we very much would encourage you to kind of give us feedback on like what sort of things you care about when it comes to securing services, using Linkerd. What sort of requirements you have. We're sort of like trying to build a roadmap around what's most important, and we really would appreciate your feedback of getting involved. So that's it. Thank you so much.
All right, thank you, Sebastian. You were 60 seconds over, and you will be penalized. Now I just have to plug in. So I got to imagine if this is your first kind of time coming to Linkerd, that was probably a bit of a whirlwind tour. But the reason why I wanted to work in a couple lightning talks as part of this is a big part of the Linkerd project is the community around it. And so there's a couple things, a couple next steps for you folks, and then I'm going to stop talking in about 2 minutes, and we'll have a couple minutes for Q&A, both about Linkerd and about the lightning talks. But Linkerd.io is where kind of the starting point for everything. Everything is up on GitHub/Linkerd. There's like a whole bunch of repos there, but don't feel scared. Just go for the ones that have lots of stars on them. I spend all my precious life energies tweeting from at Linkerd on Twitter, so please follow that so that I have some validation to my meaningless existence. And oh, thanks. I appreciate that. Slack.linkerd.io is the easiest way to get into Slack. A lot of the community is happening not on the email. I put the email lists up there, and I encourage you to join those because every once in a while we send out an important email. But a lot of the community is happening on the Slack, and we've got a little auto inviter on Slack.linkerd.io. And then once we're done with Q&A, you should feel free to stay here for Oliver's deep dive on 2.0 and all the like crazy decisions that we made, hopefully not crazy decisions that we made in that transformation. And then if you don't like Oliver, Michelle Nurali from Microsoft is actually giving a talk in Ballroom 6E, debugging Kubernetes apps. That's going to have a big Linkerd component to it. So you just vote with your feet, Michelle or Oliver. Okay, with that aside, why don't we open it up for Q&A, either to me about Linkerd stuff or to any of the Lightning Talk presenters. Yes?
Can you summarize for the newbies here why and when we would use this versus the other mesh technologies?
Yeah, okay, so the question was, when should you use Linkerd instead of the other mesh technologies? I have a lot of opinions on this. And since we're in a public forum, I'm going to give you the public forum answer, which is that you should try them all and pick the one that is the easiest and fastest and simplest and lightest weight and has the best community around it, which is whichever one you decide that is. I'll say that all the yeah, there's a lot of service mesh projects. They all kind of have the same goal, right? And the goals are good, right? The goals are we want to provide visibility, we want to provide security, we want to provide reliability semantics, and we want to do that at the platform layer so that our developers don't have to do those things anymore, right? And the origins of Linkerd, come from this experience that Oliver and I had, especially at Twitter, where Twitter went through this very painful transformation and had to learn how to do all those things in a way that was not dependent upon individual developers reinventing how to do retry logic every single time. So the goals of all the projects are the same. The implementation details and kind of the focuses of the projects are very different. And I'll say, at least from the Linkerd side, it's very important to us what the operational surface area of Linkerd is. So how complicated it is to learn, how much resources it takes when you've deployed it to production. Those are things that we care greatly about in Linkerd because we expect you to deploy this yourself. And so a lot of the design decisions we've made are kind of show that those goals. But everything's open source, and you should just try it. Official answer. Yes?
For the performance tests that were done for Linkerd compared to Istio, I wonder if you could maybe just touch on that a little bit and kind of what the findings were.
Sure. Ivan, do you want to come up? So the question was, Ivan mentioned he had done some performance tests on Istio versus Linkerd.
And also, too, if you did anything related to Linkerd versus doing something with like straight Envoy or something like that.
And also, did you compare Linkerd to straight Envoy?
So I'll answer the second question first. Like in the performance test that I did, I compare Linkerd to an SDO only, because I think Envoy is more like the proxy, right? So I feel like if I want to compare that without the control plane, it would be comparing Envoy with the Linkerd Rust proxy. So I think the too long didn't read result is I basically run all of these on GKE, and I use Fortio, which is the SDO performance test tool, to compare the performance latencies. And at the end of the day, the baseline from the load generator to the echo servers could handle about say 30,000 query per second HTTP queries. And SDO is in my setup is a lot lower. It's about 3,000 to 4,000 query per second, whereas Linkerd is somewhere just in between, so around 11,000 query per second. In terms of latencies, it's somewhere the baseline was about 6-7 milli per second, and then on the not far on the other end, SDO is about 30 to 40 milliseconds, and then Linkerd again is somewhere in the middle. Not really middle, but maybe 8 to 12 milliseconds. I have the charts there. If I can show you how I set up the clusters and stuff like that. I put it all up on my GitHub repo. We can talk more about it later if you buy me a beer or two. Thanks.
All right, thanks, Ivan. I'm sure Oliver will talk a little bit more about this, but a lot of the work that's gone into Linkerd 2.0 has been on the proxy side. We've invested heavily in Rust, in the Rust ecosystem, and as a result, the 2.x proxies are incredibly fast and incredibly small and have very good memory behavior. All right, let's do the gentleman over there. Yes.
Yeah, so something neat I've recently learned about Envoy is that its community is using it for all sorts of different things. It's a very general purpose proxy that can be configured in many different ways. And it's not necessarily geared specifically to service meshing things. How would you describe the Linkerd 2 equivalent proxy? What is it designed for?
Yeah, so the question was, one of the things that you like about Envoy is that it's a general purpose proxy and can be used for a lot of different things, and the community is doing it. What about the Linkerd 2 proxy? Should I leave that question for you, Oliver? Oh, all right, he's going to come up and answer it. Now you've done it.
Howdy. So just to repeat the question so I know it, Envoy is a very general purpose proxy like Nginx or HA proxy. It can be deployed in all sorts of configurations and a bunch of, you can build your own service mesh with it for all you want. And we did not make that decision with Linkerd 2 because we want these things to be really tightly coupled. And I think I can talk about this a little bit more in my next talk, but you'll see that we have APIs that Envoy doesn't have, and that's fine because we're building this for the UI and the CLI and the actual users who are using the service mesh. So you could build something like Linkerd with Envoy, but that just wasn't really our goal. That said, it is possible to take the Linkerd 2 proxy and run it without this control plane and replace the control plane API with another thing. I know some other companies who are not here are starting to play with that sort of thing, but we do not really focus on that general purpose nature of the proxy.
Having ownership of the entire proxy layer has also allowed us to do a couple things, like I don't know if Oliver might get into this, but the tap feature, and especially next year when we start getting into tap bodies and stuff, there's some cool, very cool stuff we can do. All right, I think we have, yeah, we got time for more. All right, in the back. Okay, so we're focused on avoiding feature bloat. Are there features that are available in Istio that will never be part of Linkerd? I have a hard time answering that because I don't know the full Istio feature set. It goes on for pages and pages. I'll say, let me instead compare it to Linkerd 1.x, which I know very, very well. So Linkerd 1.x, which we built on top of the Twitter stack, had this incredibly powerful language for configuring routing policy, and it's called dtabs. And it allowed you to do all sorts of crazy things, and it was expressed in this very natural form, which is a backtracking hierarchical, nested thing with like all this. Yeah, it was complicated, and so for 2.x, when we're talking about routing, well, 2.1 actually has no like traffic shaping of that sort, I should say. When we do that, we're not going to do dtabs, right? And that's not because dtabs are bad. It's because they are complicated and like there's better ways of describing that kind of routing policy. But the only reason we got to, came to that conclusion was because we spent the past couple of years like trying to help people do stuff with dtabs. So there are certainly lots of features that we have considered that are not going to be part of 2.x. Whether those are features on the Istio roadmap or not, I don't really know. All right, keep going. Ask me the hardest question you can. I'm on the hook. It's being recorded. What's the worst thing about Linkerd? The worst thing about Linkerd is how amazing it is. That's easy, guys. What's the best thing about Linkerd? I was going to say the community, but maybe it's just like how amazing the Twitter account is. Yes.
The mutual TLS chart, what do you do when there's a network partition and your certificates are now expired? Or how does that?
So with mutual TLS, what do you do when there's a network partition and your certificates have expired? Sebastian, you want to answer that? I think the answer is it just breaks totally.
I would say the answer is that your certificates are usually, like I took an extreme case here, but like 1 minute. You would like probably have a validity of like an hour or like 12 hours or 24, and it retries. So when a network partitions, then you have like bigger problems, right? So like ideally you would get back to a place where it then would continue and it would renew it. So if you have like let's say 12 hours of certificate validity, maybe you start renewing it like a few hours in, right? And you kind of make sure it never expires. Yeah.
I think I have did I put in a diagram here? No, I did not. I thought I had like an architecture diagram. Oh, no, I did. It's just totally frozen. All right, we're stuck on this slide. I was going to show off an architecture diagram to get your creative juices flowing. All right, we got a couple more minutes. Yes, question in the back from a stranger who I've never met before. What is the coolest feature in Linkerd that in the 2.x branch that will be coming soon? I don't know. What is it? Okay, so let me talk about some of the things that are coming up on the 2.x branch. A lot of what we released 2.1 just recently, and I'm probably just stealing content from Oliver's talk entirely, so oh well, too bad for him. We released 2.1 last week. What 2.1 introduced, which was a major step forward for the project, was this idea of service profiles, which have a lot of interesting capabilities, but one thing that they allow us to do is to hang configuration off of service objects. And now that we have that, which has been kind of a big hurdle to get over, we now have the ability to start adding all the things that we want to do around how do I parameterize and how do I control the way that Linkerd deals with my traffic for a individual service. So, ranging from how is it doing retries and circuit breaking and things like that, all the way to even fancier things that Oliver's gonna talk about. So I personally am excited about getting things like tap bodies in there, where we can, right now, you can basically ask Linkerd, hey, in this live request, this live stream of traffic, give me some of the request response headers, right? Let me just see what's going on. That's kind of like TCP dump for microservices. We don't have the bodies wired up for complicated computer reasons, but once we have bodies in there, then we start getting into a crazy world of, okay, well now I can actually, siphon off live traffic. I can save that. I can replay it. I can do all sorts of really exciting things. So that's on the horizon. There's also a bunch of work if you are into like Kubernetes security policy and stuff like that. This might be exciting to you, but one of the issues that the more lockdown environments come up kind of butt into when they're installing Linkerd is the way that the Linkerd pods get injected into the sidecars involves this init container that does a bunch of IP tables magic, so that we automatically route all the traffic through the sidecar proxies. Granting that it's called netadmin capability to kind of arbitrary users is not always what you want to do. So there's a bunch of work to move that privilege escalating code out of the hands of individual developers and into the hands of cluster operators who are safe and secure. So that's by definition. So that's coming up soon too. That may or may not be exciting. Okay. Wow, we're over time. I'm sorry for that. My laptop is frozen. As you can see, it says 2:12 up there, so I've just been trying to buy time, and it hasn't been working at all. So thank you very much, and stick around for Oliver's talk.